Hey everyone. I think we all know the feeling you've got this awesome 3D model in your head, but getting it from your brain to the computer, well, that can be a real pain.
Yeah.
What if you could just tell an AI what to build?
Yeah, well, we're going to dive into a paper today that just might make that possible.
Okay.
It's called LLaMA-MESH, Unifying 3D Mesh Generation with Language Models.
Catchy, right.
But it's a mouthful.
It is a bit of a mouthful. Don't worry, we'll break it all down for you.
Yeah.
So this deep dive, this is really for all you AI folks out there, researchers, engineers, anyone who wants to get a handle on this tech.
And trust me, this is cool stuff.
It is.
We're talking AI that can not only understand language, but also grasp spatial reasoning.
So imagine the possibilities.
Exactly.
So let's get right into it. What makes LLaMA-MESH so special?
Well, I think the big aha moment with this paper is that it's the first to bring 3D mesh generation right into a large language model, right into an LLM. We're not talking separate tools here. It's one unified system.
Oh, I see. Okay. So it's kind of like, well, how does it actually work? Does the AI have to learn like a whole new visual language or something?
You know, that's what I thought too, but it's actually way more clever than that. They use the OBJ file format, which if you're familiar with 3D modeling,
Yeah.
It's just plain text describing the vertices and faces of a model. It's nothing fancy, but it works.
So they kind of like sidestep the whole visual learning thing by using something that already exists.
Exactly. It's all about leveraging the power that LLMs already have, no need to reinvent the wheel. And they actually had some pretty interesting early results.
Oh, yeah.
Yeah, if you look at figure 6 in the paper, remember those early attempts at AI-generated OBJ files? Like that simple bench?
Oh, yeah, yeah. It was a little rough around the edges, wasn't it?
Yeah.
I mean, but still kind of cool to see an AI trying to make like a physical object. Right?
It was definitely a proof of concept, but it kind of showed that LLMs had some sort of spatial awareness lurking in there somewhere.
Right, like tucked away in all that language data.
Yep.
Okay, so LLaMA-MESH takes that basic idea, that potential, and really runs with it.
They basically took an existing LLaMA model and fine-tuned it on a massive data set of, text mesh pairs.
Okay, so like text describing an object paired with its actual 3D mesh.
Exactly.
Where do you even get a data set that big?
They use the Objaverse data set. Have you heard of that one?
Rings a bell.
Yeah, it's huge, like massive collection of 3D objects. But even with all that data, they had to use some clever tricks to make it manageable. They used something called vertex quantization to reduce the complexity.
Ah, makes sense. So how did the model do? Did it actually learn how to sculpt with OBJ files?
Well, I was actually surprised by how quickly it picked things up.
Really?
Yeah, you can see in figure 9 the learning curve was pretty steep. It's a testament to how adaptable these LLMs can be.
It's awesome.
Yeah.
Okay, so they've got this language model that can now essentially speak OBJ,
Yeah.
right?
Mm-hmm.
But can it do more than just create these 3D models?
That's where things get really fascinating. Because LLaMA-MESH doesn't just create visuals. It can understand them too. Like you could show it a 3D model
Oh, wow.
and ask it, what is this? And it could identify it.
No way.
Yeah.
That's incredible. So it's not just outputting OBJ files. It's actually like analyzing existing ones too.
Exactly. Like in figure 7, it's able to look at a car bumper bracket and identify it. It can even describe things like the purpose of the holes in the bracket.
Hold on. It's got that level of understanding. That's huge. I mean, think of the applications for robotics, AR, VR.
Absolutely. This could be a total game changer. And it gets even better.
Oh, no, there's more.
There's more. It's not just a one-way street. You can actually have a conversation with LLaMA-MESH to refine your design. Imagine saying, make the chair legs thinner.
And it just does it.
And it updates the model in real time.
Wow. I mean, that just opens up 3D modeling to anyone, right? You wouldn't have to be an expert in all the technical stuff.
Exactly. It's about accessibility.
Okay, but let's be real. How does it actually stack up against the big 3D generation models out there?
Right.
I'm looking at the performance comparisons here. Figure 11, they put LLaMA-MESH up against MESH-XL and Unique 3D.
Yeah, so those are two of the leading models right now, and the results are actually pretty impressive.
Yeah.
Not only is LLaMA-MESH competitive in terms of the quality of the 3D models that it can produce,
Okay.
but it's also way more efficient to train, and that's a big deal, especially for researchers and engineers who might not have, unlimited resources.
Right. I mean, efficiency is key.
Absolutely.
So it's not just about pushing boundaries. It's about making this technology actually practical, right?
Exactly. And that's what makes this paper so exciting for the AI community. It really signifies a potential shift, from those really specialized AI models that we've been using for 3D generation to something way more general purpose.
Right. And that could be huge, like democratizing 3D modeling.
Exactly. It would open so many doors, especially for smaller teams and independent researchers.
Yeah, I mean, just imagine the impact on the research landscape.
Yeah.
We could see an explosion of creativity in 3D modeling applications.
Oh, absolutely.
We've talked a lot about visuals,
Yeah.
creating these cool models, but LLaMA-MESH seems to be able to do so much more than that. What other applications are we looking at here?
Well, think about robotics. With LLaMA-MESH, robots could potentially start to understand their environment in a way that's like way more nuanced.
Okay, so like not just recognizing that there's a chair in the room,
Exactly.
but actually understanding like how to interact with that chair based on its shape and structure.
Right. Like imagine a robot that can not only see a chair, but actually knows how to, pick it up or move it around.
Wow. So we've talked about robots being able to see for a
Yeah.
while now, but this is adding a whole new dimension.
It really is.
It's not just object recognition, it's like real 3D spatial understanding.
And that could be crucial for, tasks that need like dexterity, spatial reasoning,
Right.
like grasping objects or navigating like a really cluttered environment.
Or even surgery.
Oh, yeah. Things like that.
Wow. I mean, the potential there
Yeah.
for advancements in robotics and automation is just like enormous.
Absolutely. And what about AR and VR?
Ooh, yeah. I mean, we've all seen those like early VR experiences where the interactions feel super clunky.
Yeah.
Could LLaMA-MESH be the key to making things more intuitive, more realistic?
I think it could be. Imagine designing and manipulating virtual objects just by, speaking. Right. Or even having like an AI assistant that helps you build virtual worlds.
Okay, that would be wild. Like just tell the AI what you want and boom, there it is.
Yeah,
And
exactly.
that'd be huge for gaming, design, even education. So many possibilities. It feels like we're like on the verge of a major leap forward in how we interact with the digital world.
It really does. And I think this integration of language and 3D understanding could have huge implications for other fields too.
Yeah.
Like imagine scientists using LLaMA-MESH to, model molecules or design new materials.
Oh, that's a good one.
Or architects designing buildings.
Oh, yeah. Buildings that are not just like aesthetically pleasing, but also structurally sound.
Exactly.
I mean, it's just fascinating to think about how this technology could ripple out across like every industry. It's not even just 3D modeling anymore. It's about like fundamentally changing how we approach design and problem solving.
It really is. It's like bridging that gap between language, how we communicate and conceptualize things,
Right.
and the physical world, the world of like shape and form.
Okay, but we've talked a lot about the potential benefits,
Yeah.
all these exciting applications. But like any powerful technology, there are also risks, right?
Yes.
How do we make sure that LLaMA-MESH is developed and used responsibly?
Right. And I think that's where, us AI researchers and engineers really need to step up.
Yeah.
We have a responsibility to think about the bigger picture, like the societal implications of our work.
So not just getting caught up in the cool tech, but also thinking about like the unintended consequences.
Exactly. And, developing some guidelines and best practices for ethical development and deployment.
Especially with something like LLaMA-MESH, which could have such a huge impact on, robotics, automation.
Absolutely. I mean, we need to make sure these advancements are used to enhance human capabilities,
Right.
create a more equitable, more sustainable future.
Yeah, it's a fascinating challenge, isn't it? I mean, on the one hand, we have this incredible technology that could revolutionize so many things, but on the other hand, we need to approach it with real caution and foresight.
It's a tightrope walk, for sure.
It is. It really is. But that's kind of what makes this whole field so exciting.
That is.
We're not just like coding here.
Yeah.
We're shaping the future.
And with LLaMA-MESH, that future is looking pretty three-dimensional. It's like we're teaching AI to see the world, interact with it
Yeah.
in ways that we could only imagine before.
We really have covered a lot of ground in this deep dive, haven't we?
Yeah.
The technical breakthroughs, the potential applications, even the ethical considerations.
Yeah.
But I keep coming back to this one question. What are the limits here? Like, what are the limits of what AI can actually learn about the physical world?
That is the million-dollar question,
It is.
and I don't know if we have an answer yet. But I think what LLaMA-MESH shows us is that the boundaries are, always moving.
Right.
We're going way beyond text and images now.
Yeah.
It's a deeper understanding of shape, structure, spatial relationships.
So what happens when we take LLaMA-MESH and combine it with other emerging tech?
Right.
Like, I don't know, bioprinting, nanotechnology.
Oh, okay. Now we're talking. Now things are getting really interesting. I mean, you could be talking about using language to design like entire biological systems.
It will slow down. So you're saying, like, I could describe a new type of plant or even an organ,
Yeah.
and an AI could turn those words into a 3D blueprint and then, like, actually build it.
It sounds crazy.
It does sound a little crazy, but it's also kind of like,
A little bit daunting.
yeah, a little daunting, but
Maybe.
mostly
Yeah.
exciting.
Oh, for sure.
It's like, this is the future, and it's happening now.
It is. And it's up to us, to guide it.
So for all you AI researchers and engineers out there listening,
This is a call to action.
LLaMA-MESH, it's like a glimpse into what's possible. We're at the forefront of this incredible revolution, and it's our responsibility to make sure that this technology benefits all of humanity. Keep pushing those boundaries, keep asking the tough questions, and keep exploring the possibilities. Who knows what we might create when AI can truly think and speak in 3D? Thanks for joining us on this deep dive.